Hi, I'm Princess Senate, conference producer at Technology Networks, and I am here to introduce our final talk of the day, the emotion paradox, behavioral science in food research. I am pleased to welcome Dr. Michelle Niedziela. Dr. Niedziela is a behavioral neuroscience expert in neuropsychology, psychology, and consumer science. Experience from academia from Monell Chemical Senses Center and industry, Johnson & Johnson and Mars Chocolate in R&D of innovation technologies and methodologies for consumer research. As Vice President of Research and Innovation at HCD Research, Michelle focuses on integrating applied consumer neuroscience tools with traditional methods used to measure consumer response. A warm welcome to you, Michelle. Following the presentation, we will have a Q&A session and we welcome any questions that you may have. Please ask questions using the Q&A system to the right-hand side of the video player. You can also use this feature to connect with attendees and discuss the talk. So feel free to take advantage of the chat system by introducing yourself and sharing your thoughts during Michelle's presentation. You can also benefit from some fantastic supporting literature, which you can download for free below the video player. If you experience any technical difficulties during the presentation, please request help using the technical help icon in the menu on the left-hand side of the player. I will now hand over to Dr. Niedziela to begin her presentation.
Hi. As Princess said, my name is Michelle Niedziela, and I am VP of Research and Innovation at HCD. During this talk, I'm going to provide a brief review of behavioral science, psychology, and neuroscience, and how applying these sciences to consumer research can be useful, along with some cautions on their use. Some of these concepts you may already be familiar with, but the field is constantly changing, so it is always a good idea to have a refresher, as well as hear what may be new. You can also check out HCD's website, which has really informative resource pages, including things like white papers, poster presentations, infographics, and even a podcast with episodes called Mindset, which is a podcast that I host. And it can be found wherever you get your podcasts, dedicated to this very topic. I'm going to do my very best to give an overview, but for more in-depth explanations, please feel free to check that out. I would also be more than happy to answer any questions during and at the end of this presentation, but please feel free to connect with me directly on LinkedIn or via email. Now, 100%, this is a cheesy attempt at a joke slide. Why is there a neuroscientist in my soup? Because people are often confused about what I do as a neuroscientist. When I was in my postdoc trying to explain both neuroscience and sensory science research, and then when I was a neuroscientist working at J&J and working on things like baby shampoo, Rogaine, and Lactate, or even KY. And maybe most confusing was when I said I worked at Mars Chocolate. Why was there a neuroscientist in my chocolate? It's only a little bit easier now working for a research and consulting company because at least there is research in the name, and so people can almost get it. So what does a neuroscientist do at these companies? The main similarity in all of these roles was that I was using my expertise to help guide research design, glean insights from data, and create innovations for consumer products. And I really like what I do, even though it's pretty complicated to try to explain. For those of you that may be unfamiliar with HCD or this sort of approach, we use a combination of behavioral, cognitive, and neuroscience tools to understand consumer perception and ultimately their behavior. With tools from psychology, neuroscience, and traditional market research, we can help companies figure out the best ways to harmonize their brands and products to meet consumer needs. I'd also like to mention that we are very active academically, as well as in industry communications and education, for example, through our free annual symposium we call NeuroU. Here, we invite people from industry and academia to present and discuss the latest science and applications in an effort to get both providers and clients a strong basis and equal footing understanding of these tools and applications, and most importantly, dispel the pseudoscience that often plagues this field. So let's jump right into it. We live in a world where we are bombarded with information all of the time. So for example, while shopping in the store, we hear music, we see brands all around us, we see other customers, so on and so forth. It's a lot to sort through when we're trying to make consumer decisions, from what to buy or even how to navigate the store. Our intentions with the world around us are driven from how we interpret our environment psychologically, neuroscientifically, and behaviorally. Part of what we do at HCD is help clients like brand companies and food companies figure out how to break through that clutter and best engage with their customer. And in order to do that, we need to understand what makes the customer tick. And in doing so, we hope to find better ways to engage with the consumers as they're making their choices. When making decisions, some might say we can be of two minds, our inner Homer or our inner Spock. Our Homer runs on impulse, while our Spock runs on planning. This concept of dual theory is something that's seen throughout history, whether it's philosophy with the chariot's allegory, Freud with the id, ego, and superego, and more recently with behavioral economics and Kahneman's systematic thinking. In psychology, a dual process theory provides an account of how thought can arise in two different ways, or as the result of two different processes. Often the two processes consist of an implicit unconscious process and an explicit conscious one. These two forms of processing provide complementary benefits. So tasks can be learned quickly via controlled processing, but are slow, serial, and effortful, and non-robust. After much practice at doing something, it can be performed then much faster and with a lot less effort with automatic processing. So dual processing theory provides the most compelling explanation how both intuitive and rational cognitive processes integrate information on benefits and harms and provide not only descriptive assessments of decision-making, but possibly may lead to better understandings and insights that improve the way decisions are made. Now, economics Nobel laureate Daniel Kahneman wrote a book called Thinking Fast and Slow, in which he discussed these two ways that the brain operates. According to him, he called it System 1 and System 2, which you may have heard of since it's become quite popular these days. System 1 and System 2 encompass two different ways of thinking, again, that dual process theory. And Nobel Prize winner Kahneman devoted his life to better understanding how people think and make their decisions. So to test this out a little bit to get a better understanding, very quickly, how is this woman feeling? As soon as you saw this photograph of this woman, you surely knew that she was feeling maybe sad or distraught or stressed. You didn't have to think too much about it or spend time analyzing her facial expressions for any clues. You just know it. Kahneman calls this form of rapid, effortless thinking System 1 thinking. So you can also call this maybe your Homer. System 1 thinking is automatic, intuitive, and requires no effort. You don't need to spend any time carefully thinking it over. You just know instinctively. Now, on the other end of the spectrum, quickly, how much is 17 times 14? Now, by contrast, you probably didn't know the answer right away. You probably know how to solve it, and you know you could work out the answer, but that would require a lot of time and effort. First, you would have to go through remembering the rules of multiplication and go through each of the steps involved. And you might be able to work it out, multiplying 17 times 10 and then 17 times 4 and adding those two answers. Doing so requires a lot of manipulating of numbers in your head, taking up all of your working memory and sapping your concentration. And Kahneman calls this slower, conscious, and rational style of thinking, System 2 thinking, or your inner Spock. System 2 thinking is very deliberate and effortful, requiring mental work and concentration. And in fact, when you're engaged in System 2 thinking, your body is also involved. Your muscles tense up, your blood pressure rises, and your pupils dilate. They get bigger. So which system is better? Well, that depends on the task. System 1 gives us this fast, effortless answer, but it also is very prone to errors. System 1 uses mental shortcuts to come up with an answer in a very little time, but sometimes these mental shortcuts can lead to the wrong answers or biased answers because you don't think them through. The concept of systematic thinking has become quite popular recently. However, with popularity and buzzworthiness of any theory or concept also comes a lot of misuse, misunderstanding, and very often overgeneralization. In recent years, there have been quite a few companies that suggest that the key to marketing or consumer success lies in ignoring System 2 and focusing only on System 1. They often push an idea that the majority, sometimes even quoting 90%, of all decision-making is non-conscious, suggesting that clients should forego using traditional survey-based explicit methods for instead asking research questions for more System 1 or non-conscious or implicit methods, saying that consumers lie or that System 1 is unbiased. Unfortunately, that and many others of what we call neuromyths are untrue. And my hope is that with this sort of intro beginning, we can arm you with the tools you need to navigate implementing these types of tools in your own work and organizations in the best ways possible. So again, we can kind of call our system 1 our inner Homer and our system 2 our inner Spock to some degree, right? Or a step further, you can call your Homer your emotionally driven decision making, and your Spock your more rationally driven decision making. Which leads to an interesting question. What is emotion? Emotion is often defined as a complex state of feeling that results in physical and psychological changes that influence our thoughts and behaviors. Emotion as a concept actually didn't exist until the 17th century. Before that, it was all about passions and sentiments, which is a slightly different idea. Emotions are mental states brought by neurophysiological changes that are associated with thoughts, feelings, behavioral responses, and a degree of pleasure or displeasure. There is actually no current scientific consensus on a definition. Emotions are often intertwined with mood, temperament, personality, disposition, or even creativity. And the research on emotion has actually increased over the past 2 decades, with lots of different fields starting to contribute, including psychology, obviously, but also medicine, history, sociology, and even computer science. The numerous theories that attempt to explain the origin, function, and other aspects of emotion have fostered more intense research on this topic. Current areas of research in the concept of emotion include the development of materials that stimulate and elicit emotion. The bottom line is that emotions are very complex. So to better understand that, we need to understand why studying emotions is so complicated. So there are many theories out there. Yes, theories, meaning we don't necessarily have any sort of scientific consensus. One approach to understanding emotion is through physiology, as you can see here on the screen. Physiology of emotion is closely linked to arousal of the nervous system. And the 19th and early 20th centuries were heavily focused on this idea of measuring physiology. So emotional theories of this time that were being introduced were boiling emotion reactions down to physiological states of being. So like the James Lange theory is a hypothesis on the origin and nature of emotions and is one of the earliest theories of emotion within modern psychology. And here they state that emotions occur as a result of physiological reactions to events. This theory suggests that seeing an external stimulus leads to physiological reactions. So you see a bear, your heart begins pounding and sweating, and then you feel fear. Now, on the other hand, the Cannon-Bard theory states that the lower part of the brain, also called the thalamus, controls your experience of emotion. At the same time, the higher area of the brain, called the cortex, controls the expression of emotion. So stimulating events trigger feelings and physical reactions that happen at the same time. So you see the bear, and your brain triggers you to feel fear, while at the same time, your brain also causes your heart to start pounding. So these two things happen at the same time. Now, the Schachter-Singer theory of emotion, also known as the two-factor theory of emotion, states that emotions are a product of both physiological and cognitive processes. First, emotional stimuli elicit a physiological response, and then we cognitively appraise this physiological activity and try to give it a correct label. Now, then there's Paul Ekman and people that use categorical emotional theory. And in this, they believe that there's a set of emotions that are universal, meaning that people all over the world can recognize and also experience these emotions. So 6 of these are considered the basic emotions: happy, sad, fear, anger, surprise, and disgust. And according to Ekman and those like him, you can recognize these emotions by categorizing facial expressions. Now, a couple of things that you can actually note here within this is that if you are limited to these 6 basic emotions, there's only one that is positive, happy, while the others are, for the most part, negative emotions. And this can make it really challenging to expand upon the entire experience of emotion that we know we experience. And so this can be quite a bit of a problematic theory, and it's been shown to be very troublesome, especially when trying to measure consumer reactions to things. And this finally brings us to Lisa Feldman Barrett and her theory of constructed emotion, and also where the idea of the emotional paradox comes from. Now, for Lisa Feldman Barrett and people that subscribe to this theory of emotion, you experience a stimulus and your brain begins to appraise that stimulus and the environment that you're in before it constructs an emotion. And this is through something that is learned. So you learn how to appropriately react, and it's very context driven. And that reaction of emotion can express itself through your physiology, how you're feeling, how you behave, as well as on your face, and even in your vocal acoustics. So now this is quite different. Every one of these theories is quite different, which is what makes it very complicated to study emotion, and why we talk about this as the emotional paradox. The paradox is that while we believe that we know what emotion is, so if I were to ask you what is an emotion, you feel that you know what an emotion is. You can name many different types of emotion. You know an emotion when you feel it. And that makes you believe that it is therefore easy to measure emotion. But as you can see here, with the multiple theories that exist, it actually becomes quite complicated, as the different measures don't actually match up across all the theories. So Paul Ekman, for example, introduced the idea of facial coding because he's relying on the facial expressions as being a way to measure emotions, whereas the physiological theories rely upon physiological measures of things like heart rate and galvanic skin response. So that is, again, going to be quite different than what you get from reading on the face. Lisa Feldman Barrett looks at more of like a combination of these things, understanding that constructed emotion is going to involve your entire body. And so this makes it quite challenging when you're trying to decide which methodology to use, as it is not quite as simple as we all, assume that it is, which is that emotional paradox. So what is the brain and how is it controlling emotion? Now, when we talk about the brain, we are talking about neuroscience. And neuroscience is actually an incredibly broad science. Neuroscience is the scientific study of the nervous system. It is a multidisciplinary science that combines physiology, anatomy, molecular biology, developmental biology, cytology, computer science, and mathematical modeling to try to understand the fundamental and emergent properties of neurons, glia, and neural circuits. Neuroscientists focus on the brain and its impact on our behavior and cognitions. Not only is neuroscience concerned with the normal functioning of the nervous system, but also what happens to the nervous system when people have some sort of disorder. A further breakdown looking into the brain, it's about 3 pounds of tissue that dictates literally everything we do, how our bodies function, how we survive, how we think, and what we do. And the brain is actually made up of 100 billion neurons and 100 trillion connections, all working together seamlessly to keep us alive. So essentially, we are all just electric meat. And that's not trying to be reductionist or depressing. It's really quite amazing when you think about it, and quite complex, which is an important part to recognize because we are complex. Humans are difficult to understand. The brain is not simple. So when we think back again to those emotional theories, we are not just heart rate. We are not just facial expressions. And it's also important to realize that even neuroscientists cannot read minds. If our brains were that simple, we would be no more complex than a sea slug, which is in fact the ideal model for neuroscientific study because its nervous system is actually visible and quite simple. Our brains, on the other hand, have all those trillions of connections, but also different structures dedicated not only to complex thought, but also to just keeping us alive. And all of these structures and activities and connections are not only redundant because they are so important for keeping us alive, but also contradictory to help us stay in control and homeostasis. The brain is busy all of the time, running literally everything we do. And it's certainly not just 10%, as you may have heard. So this image here is a great overview of the different types of modern methods of measurement looking at neuroscience and physiology, some of which we'll dive into a little bit more. All the way on the right, we have some neuroimaging methods like fMRI and EEG that involve the central nervous system, while others like heart rate and skin conductance are measures that are of the peripheral nervous system, which is everything outside of the brain, because these are correlated with the processes in the brain. And all these tools have specific roles they can play in telling us information. There's no silver bullet or one size fits all. These tools all have limitations that must be considered. And there are instances where none of the tools listed here will help, and it's better to just use traditional measures like survey. Through intentional research design and working with a research question, we can begin to tease apart these tools and how we can utilize them to maximize differentiation in our results. So how can these measures be useful in industry and consumer research? Well, when we look at how our brains are interacting with the world around us, our brain actually starts by forming impressions. So if we're talking about food, this could be that we taste something. So we are not fully aware necessarily of all the intricacies that are going on when we interact with our environment. So for example, if you're hearing, you are not constantly paying attention to the sounds you're hearing all around you, but your brain is taking in that information constantly and forming impressions to decide what you should pay attention to. So your brain is doing this non-consciously, but as it starts to determine meaning and value and it decides that it's important and says, okay, that is a sound that's nearby me, it's quite loud, it is something I recognize, it is a cell phone, this starts to move into more conscious thinking. So as you start to deliberate more and analyze that sound, you say, oh, wait, that is a cell phone, it is my cell phone. Then you have fully conscious thought where you're starting to think about what you want to do. Do you want to answer that cell phone? So when we think about this from an industry perspective, we might be able to change some of those early signals that actually influence behavior. So whether it's a flavor that triggers you to feel a certain way that's going to change how you behave, or maybe a sound, we change the tone quality or the frequency of the sound, and that maybe will cause you to react faster, whatever it might be. These are the types of things that you can use these physiological, neuroscience, psychological measures to really manipulate and better understand. Behavioral sciences, or applied consumer neuroscience, is using a combination of methodologies from neuroscience and psychology, as well as your traditional survey methodologies. And by combining these together, it is possible to examine and study how the consumer is perceiving, evaluating, and responding to stimuli, and better understand those traditional research questions that you might ask. So for example, with something like liking, you might be able to better understand why somebody likes something, or if you have similar products that are all ranking similarly on liking, you may be able to use some of these other additional measures to further differentiate those product experiences. Another thing to mention here is that these tools are also becoming more common in everyday life. Most of us know someone who owns a Fitbit, or like I have an Apple Watch, and recently something like the Oura Ring has risen in popularity for monitoring heart rate, sleep, and temperature changes. You can even easily access and acquire an EEG headset by doing a simple Amazon search. These measures do not require a special degree or a license to buy them or use them. It just takes funding. So when exploring different vendors who have access to these measures, it is important to properly vet them to ensure that they are using them appropriately and not overpromising interpretations of the data. So to conceptualize things, we bucket general concepts or approaches to help mix and match which methodology best works with our research question. Using a combination of methodologies, we can examine and study how the consumer is perceiving, evaluating, and responding to these products within physical environments or even digital ones like websites or apps. Diving a bit more into these buckets, physiological measures can include the use of modern brain science to connect stimuli with autonomic responses, while psychological assessments use implicit responses or academically validated assessments or emotional batteries to get an understanding of mood states or perceptions. And just kind of like what we talked about earlier with the different theories, the different measures that you use do subscribe to different theories. So they're really telling you quite different types of information, and each one does not give you the complete picture. Behavioral measures, on the other hand, do focus on observing the action of the consumer using tools like behavioral coding or eye tracking to identify things like key motivators or barriers to behavior. Consumers are constantly changing, and we recognize that we need to innovate to grow with them. And this involves thinking outside the box to also integrate tools that consumers are already using, like their own phone. With all these measures I mentioned, while they're exciting and valuable, this type of work should not be done in silos and should really only ever complement and never replace traditional market research methods like interviews or surveys. So just to dive a little bit further into this today, this is implicit association testing, which you may have heard about in some other presentations or maybe in the news, something like that. Implicit testing is a tool from psychology that explores biases through looking at reaction times. Basically, the faster you respond to something, the stronger your association, and the longer it takes for your response or no response, the weaker the association. So if you look at the example here, the participant has to decide if a pie and the word tasty belong together. If participant feels the word and the item are a good match, they just simply click the screen or tap the screen. Again, the faster they do, the stronger the connection, and the longer it takes them, the less the connection. And the test goes through different descriptors and different desserts to determine the differences in associations between the words. The tool uncovers your implicit responses and biases by going off that response time, which is not something that is consciously decided by the participant. So looking at the results here, there is a particularly strong connection with pies being tasty, more so than ice cream or pastries. And you can see that the different certainties and strengths of the autonomic associations within the chart, with the high, medium, and low associations reflecting the strength of the association and bolding indicating how many participants agreed. Next up is a measure of emotion known as the self-assessment mannequin, which is a pictorial nonverbal scales that looks at three-dimensional pad model of pleasure, arousal, and dominance, which is yet another theory of emotion. The three dimensions helps differentiate each emotion and ultimately create value to be mapped out visually. For example, being angry and afraid involves feeling unpleasant and intense, but the two emotions separate when you add the third dimension of approach and avoidance. So if you're angry, you would be approaching something, while fear has more avoidance behavior. By teasing emotions like anger and fear apart through the dimensions, you can gain numeric values that you can do statistical comparisons with. Also, SAM is great because participants can review an experience in its entirety, uninterrupted, because it is a nonverbal scale by simply choosing the best associated with their reaction to an experience. Facial coding is a method used to categorize faces for emotions being expressed. This is a behavioral measure because it is determined based on the observations of facial expressions only. This measure was made popular, as I mentioned before, by Paul Ekman's work with the 6 universal emotions. And these 6 emotions were chosen based on trends, Ekman noticed, but he later included contempt as a 7th basic emotion as well. Facial coding is usually performed using AI, such as including a webcam to take video and then using AI to analyze those videos. But there are expert facial coders as well that can be employed in efforts to mitigate common issues. For example, facial coding has actually been criticized because of the way it was developed and the inaccurate biases that it can actually perpetuate. People all over the world emote differently based on cultural differences, which is not accounted for by this measure. The facial expressions were originally collected by actors displaying what each emotion represents, which means that these are based on performative acts of an emotion rather than truly experienced ones. Emotions are also context specific, as we learned from Lisa Feldman Barrett. People frequently mirror what they see in front of them, which may not represent how someone is feeling. And although there are many things to consider when thinking about using facial coding, this tool can be useful when exploring challenging populations like infants. You can also use something like behavioral coding, which is very simple and non-invasive tool where you basically watch people with observations. And then you can look at the frequency of pre-identified behaviors to be able to run statistical analyses and look for trends. Also, by quantifying a person's actions, you can look at naturalistic interactions by comparing behaviors through different labels that you assign. These labels or codes can be specific interactions, like how frequently somebody does something, or something like explicit decisions, choosing to do something or to avoid it. This measure can be extremely insightful for usability testing or when looking at new packaging for a product, but it can identify hiccups or pain points, or conversely, the ease of the entire experience. Eye tracking is another tool that can be really great for behavior, but it's looking at gaze behavior for the eyes and visual attention. You can get things like heat maps and order of gaze to better understand how people are looking at different products or maybe at a shelf. Physiological measures or psychophysiological measures involve anything analyzing the interaction between the body and the mental processes. And the four listed here are actually the most popular. Facial EMG measures electrical pulses in the facial muscle activities to determine the type of experience, either positive or negative, that the participant has. Heart rate and heart rate variability show the level of focus a participant is giving to the stimuli through heart rate changes. Galvanic skin response is a measure of arousal that reviews the level of interest the stimulus generates. And skin temperature is another reliable measure which determines your level of stress caused by stimulus over a period of time. EEG, or electroencephalogram, is a commonly known neuromeasure that involves placing electrodes on the scalp to infer information from the brain. Our brains are like one big electrical circuit, so we can measure this electrical activity from EEG electrodes that are placed in specific positions on our scalp. This gives us a basic idea of the potential activity in that area of the brain through the ground and active sites electrodes. In this, you can measure things like frontal alpha symmetry, which is looking at an emotional index of how positive or negative an experience is. You can also look at how engaging an experience is through looking at these different sort of scores. So when deciding to implement, a little pop quiz here, when deciding to implement an applied neuro or behavioral science approach, do make sure you have a clear and purposeful research question and set actionable success criteria. So for example, do you need the prototype to outperform a benchmark for some quality? Setting these goals up front will help to choose the most appropriate tool, as well as determine the best research design. Now at HCD, we do have clients that have come to us for a specific tool in our toolbox. For example, maybe they have some interest in neuro and think that having gear on someone's head, like something like EEG, will somehow be more legit or more exciting than some of the other methods. But again, it's important to consider the research goals. In this cartoon case on the screen from IFF, which tool would be more appropriate to use to determine which fragrance they're testing is more spiritual? EEG, unfortunately, will not be able to tell you the specific words like spiritual. It can only tell you things like that frontal asymmetry. Is it more emotionally engaging? And then facial coding, on top of presenting many of the different issues that we talked about, and even more issues when it comes to fragrance research, also doesn't have a basic emotion called spiritual, as it's not basic, for whatever that may mean. So what should you do in this case if you want to measure something like spirituality? In fact, just asking someone, explicitly asking, or perhaps using implicit association may be the only way to assess something specific like spirituality of an experience. So now finally, it does need to be pointed out that neuro does not stand alone. If you were to look at the academic work, none of the methods that are used in a vacuum. Meaning even if you're reading minds, you likely still need to ask questions. Further, none of the methodologies that I've talked about today will answer all of the questions needed, certainly not by themselves, but also none of them can accurately assess liking, for example. That still needs to be asked traditionally. So it is important to be sure to integrate data from several measures and several different sources. Now, I hope that this has helped you a little bit understand some of the nuances if you're interested in understanding the emotional impact of your food products, but also to think a little more deeply about which measures should be used. If you're thinking about incorporating this into your work, you probably shouldn't commit to only one tool. Because all research questions are not the same, or even all research experiences are not the same, depending on the context, depending on, quickly the turnaround, depending on the type of participants that you have, you may need to choose the right tool for that particular research question, as well as that right research situation. So it is important to probably consult with a research company that can help you make these sort of right decisions to better understand the consumer experience, so that you can make business decisions on potentially choosing the right ingredients that are going to convey an overall emotional impact, or even drive different perceptual qualities that can help you, have a greater impact with your consumers. So thank you so much for your time. We work really hard to put information like this together in an informative and educational way. So please feel free to reach out to myself and connect with us on our socials or website and listen to our podcast, Mindset. We put out new episodes bi-weekly, so it can be really fun to hear a little bit more about these topics, as well as interviews that I have with experts that are using these topics or using these methodologies or even develop these methodologies. So I'm going to open it up to questions from Princess, if you have any questions to ask.
Thank you very much, Michelle. As with all the talks, we are likely going to have lots of questions from the audience. I can see we have received some questions already, so I'll move straight on to the Q&A now. The first question I have for you is there one methodology that you would recommend over others for food research?
It's a really good question because, as I was kind of mentioning, there isn't a one silver bullet that's going to cover everything, but there's a couple of things to be aware of when you're doing food research. First of all is the chewing. So if you have someone that's going to be ingesting something, chewing requires a lot of facial muscles. This means that you're going to impact specific measures like facial EMG, which is measuring muscle activity in the face, but you're actually also going to impact measures like EEG. So if you had somebody that was tasting a drink or eating a food, that's going to cause a lot of noise in those systems. EEG in particular, where even blinking your eyes actually is, kind of like smashing cymbals. It's a very loud sort of noise in the system, since EEG is measuring electrical activity, and those muscle movements of either blinking the eye or moving the mouth or swallowing cause a lot of electrical activity in the head region. So it can actually block out any signal. So then you have to just be, if you must use those measures, you really have to think about your design. In a lot of cases, even with fMRI, for example, if someone was doing that, they would have to have the person have a straw that, a tube that goes to their mouth to sort of drop little bits of the flavor in their mouth. They wouldn't be able to chew because you can't move when you're in fMRI. With EEG, you might have to have someone taste and then look at the measurements, look at the electrical activity after they're done chewing, because otherwise there's just too much noise there. So if you must measure during the chewing experience, you might have to rely on some other measures. Maybe it is going to be something like the self-assessment mannequin. Maybe it's going to be something like the peripheral nervous system, looking at heart rate and skin conductance, for example, if you need to be doing those measures. Implicit association is actually something that we use probably most often with food research, because a lot of the times the words that we're looking for, the emotional reactions, are not the basic emotions, from Ekman. Usually they're things that are more higher order, like, do you feel healthier? Do you feel connected? Do you feel taken care of? Like all of these sort of higher order psychological ideas, which can really only be touched using implicit association. Facial coding can also be problematic because, again, the face is moving when you're chewing or drinking, or maybe you're obstructing part of the face. And so this makes it very difficult to use those sorts of measures. So certainly food research does require some real planning and thinking about the type of methodologies you will use.
Thank you, Michelle. Moving on to the next question. In terms of product and ingredient development, how does knowing emotion help? Can you give an example?
Sure. An example we've had recently was actually looking at nutritional beverages, where they were all strawberry flavored, and they needed to know which one to really go with. And they all performed really well on liking, right? So all of the intensity of the flavors, all of the liking, all the traditional measures you were doing, all 7 of the prototypes actually performed very well. but they were all slightly different, right? So the ingredients were slightly different, the ingredient mixes. So some things that you might want to think about there are really how those flavors create a perception. And that's where you kind of get again into those higher order perceptions that people can have. For example, if the strawberry is more fruity or more sweet, more dessert-like, all these different sort of nuances where maybe it could even be more fresh could indicate to people whether or not it's more healthy, for example. So if you're looking at a nutritional beverage, it might be important that you're signaling this idea of healthy, a perception of healthy, but also on top of that, does it match the brand? So by being able to do what we call brand harmony analysis, you can see, okay, what sort of higher order benefits are people expecting from this particular brand? Certainly some brands are expected to taste healthier than other brands, which might be expected to taste more fun, right? And so if you were analyzing that, you want to make sure that the flavors are actually meeting that brand profile so that you're meeting consumer expectations. So even if done blindly, when people taste it and it's, say it tastes fun, but they're expecting it to be super healthy, and fun signals to them in this situation that it's not healthy, then that's something that you would want to know. And something like this can certainly help you choose, amongst these prototypes, which one would be the best fit for the brand. And a lot of times these sort of higher order benefits are something that can be very challenging for consumers to convey. They might have a hard time saying that this flavor is more fun than that flavor, or that it's more healthy, or that it's implying some other sort of additional benefit. And so using some of these methodologies, maybe it could be something like implicit association, or perhaps you want the people to feel more excited or maybe even more relaxed. You could use, galvanic skin response to show that they're actually feeling more relaxed when they're ingesting this product, or this particular ingredient mix. So it can help you choose the right prototype to go with, or the right ingredient to go with.
Thank you. Moving on to the next question. You mentioned facial coding as being problematic, but it seems really popular. Is everyone doing it wrong, or does it not have real application?
I think a little bit of all of the above, right? So I think that the reason people use it is because, again, it's that emotional paradox. We think that it should be easy to measure emotions. And just like the example I gave earlier, where, I showed you the picture of the woman, and, you automatically know how she feels. So therefore we feel that it makes sense. You should be able to use, a video of a person reacting to something and use AI to analyze that video and be able to say how the person feels. The problem is that, first of all, people don't emote very much when they, say eat food. And in fact, research has shown, academic research has shown that when someone really likes a food product, they're more likely to react with a neutral face. And what's also very interesting, a particular study out of Wageningen University actually showed that when you have a particularly bad odor, for example, like rotting fish, people will actually smile when they smell it, not because they like it, but because it's so absurdly bad, they sort of laugh, right? So nuances like that can be very challenging for something like facial coding. But people use it because it is cheap and they think that it makes sense. But when you actually look at the data, you either don't see a lot of changes. So the actual emotional expressions are very minimal, especially when you're looking at, sensory type of differences. The changes are very minimal. But then also in making those decisions, facial coding actually doesn't use statistics. So there's no way to show that you're significantly happier, right? You're experiencing significantly more joy. But then also, even in looking at the output, you're limited to those 6 basic emotions. And so, if you're not looking for disgust or you're not looking for anger, then it's not going to be very meaningful to you. And for the most part, I don't think we're looking for anger when we are looking at our product experiences. That's not terribly meaningful. Understanding whether something is relaxing or if it's fun is probably going to be more helpful to people. And so it's really important to think about those sort of outcomes, because we do find a lot of time that when consumers have pushed to definitely use facial coding, that they are very often disappointed in the results they see, or they have trouble interpreting the results of what the result, what they get. which also leads to that disappointment. So, you kind of get what you pay for in that situation. So you go for this cheaper, easy option, and it turns to that you have to, redo a lot of your research, or you don't get the examples or answers that you're looking for.
Great. Thank you. It looks like we have some more time to answer another question. Can artificial intelligence help to better understand emotional reactions to food?
That is also a really great question. So it's definitely used in like facial coding, like I mentioned before, because we're using it to analyze those facial expressions, those micro expressions, and look for these little changes in the face. But you can actually also use it to analyze all of these responses together. So you can use machine learning and AI to come up with a model, right? So if you can fit together the traditional survey questions, for example, and integrate that data in with some of the machine data that you might get from, rheology of the product, or size of bubble, or whatever it might be, amount of carbonation, et cetera, and combine that also with the physiological responses or some of the implicit association responses, and you put all that data together, you can get a lot of insight into understanding how you might have drivers of emotion. So, for example, does the amount of crunch affect the amount of joy? Does the amount of sweetness affect the amount of fun, right? So really to see how these things relate to one another by being able to use these advanced statistics and modeling that can come from machine learning and AI to better understand. And of course, when you're using AI models or machine learning models, being able to incorporate more data, the more data you have, the better what the model is. And so we do have this wealth of information a lot of the times from all these different sources, whether it's the sensory panels, or the ingredients, or the chemistry, and then also these emotional responses. You can really put them all together to have a better understanding of that experience that can be very informative and helpful in understanding on maybe what you should do in the next iteration, or even look for innovation opportunities, for example, and being able to even potentially predict sales, which is ultimately what we all want to be able to do.
Yeah, thank you, Michelle. We have some time for one last question, which circulates back to methodologies. Is there one methodology that you would recommend over others for food research?
Yeah, so I feel that I think implicit association is really the best methodology, because if you are, again, looking for something that's cheap and easy to implement, it fits really easily into your traditional surveys. But it also so it's also just very cheap to do. It's very easy, and it gives you often those answers that you're looking for that are being driven by the marketing teams, right? So again, that spirituality type of thing. You can also do it online. So you don't have to have people come into a facility and get wired up in any way. So it does tend to be sort of an easy, quick test that gives a lot of very impactful information. So I do think that that's probably the best one to go with. Anything that kind of integrates into the surveys, I think even like self-assessment mannequin is a really easy entry into adding emotional measures into your research. When you start to dive a little more deeply into ingredient effects, or maybe if you have really complicated research questions, like making sure that the product is actually making people feel relaxed and trying to prove that out in a more clinical way, then perhaps using some of the neuroscientific methods, whether it's that galvanic skin response or maybe the EEG. But I do think those more complicated methodologies, because they do cost more, they are quite a bit more involved as well, and so they really are a little bit more advanced in the types of research questions that you would do, and so it's kind of like a higher hurdle that you'd have to cross to be able to really dive into that type of research and have it be meaningful.
Thank you so much, Michelle. Unfortunately, that's all we have time for today. Any questions that we didn't have time to get to will be answered offline as soon as possible. So that's it for Advances in Food and Beverages Analysis 2023. As mentioned throughout the day, all the talks from today's event will be made available to view on demand for the next 30 days. You can access the talks via the same link you used to access them today, and we will be sure to pass on any further questions you submit through the system to the relevant speaker. That just leaves me to say thanks again, Michelle, and we will see you again soon. Goodbye.